Hi, today we're talking about trigonometric functions and real numbers. This is the unit circle fully filled out with every single point, every single angle in radians and degrees. This is by far one of the most useful things to get through trigonometry. Trigonometry, one, besides being a hard word to say, is a very, very difficult subject to learn as well. So I'm going to teach you guys how to use this today. So what is the sine and cosine of angle 2 pi over 3? Well, we take a look at the unit circle for 2 pi over 3, which is right here. Now, sine is y and cosine is x. So all we got to do is copy that. So sine would be radical 3 over 2, and cosine would be negative 1/2. And that's it. That's all you do. Just use the unit circle. It makes it really, really easy and really, really fast. So to write this a little bit more formally, sine of 2 pi over 3 is that, and cosine of 2 pi over 3 is that. In other words, this is the x and this is the y off the unit circle. Go ahead and try that one. Try that one. Okay, so I get it, have a negative degree right here, which if we draw this, negative 45 would be right here. So we got to find the actual angle of this entire thing. So if we go 360 plus negative 45, we get 315, because this is 45 degrees right here. So we're going to look on the unit circle for We're going to look on the unit circle for 315. Well, if we take a look here, 315 is right there. And the x and y are radical 2's over 2. So the y is negative radical 2 over 2. And cosine is positive radical 2 over 2. And that's it. That's all you do. Go ahead and try this problem. Try this problem. Okay, we're going to use the Pythagorean identity. Now, what the Pythagorean identity is it goes cosine squared theta plus sine squared theta equals 1. So don't worry about the little square. It just means square cosine, square sine. We just write it there because it's a little bit nicer to look at. So this right here, we're going to find sine if cosine is given like that. So what we do is instead of cosine, we go negative 3/5 squared plus, I'm going to go ahead and call sine y squared, just to make it easier on me. So if we square this, we get 9 over 25 plus y squared equals 1. We're going to subtract that over. So y squared equals 16 over 25. And then we square root that, so we get y is 4 over 5. So that's what your sine theta is going to be, is 4 over 5. But it says right here we're in quadrant 3. And if we look at quadrant 3, sine is negative. So therefore this must be negative 4 over 5. So this will tell you the signs of it. And if you remember from way back in the day, quadrant 1 is positive, positive. Quadrant 2 is negative, positive. Quadrant 3 is negative, negative. And quadrant 4 is positive, negative. So in other words, cosines are positive in 1 and 4. Sines are positive in 1 and 2. Go ahead and try this problem. Okay, tan is a weird one. Tan is the same as sine over cosine. It's exactly the same thing. So basically we have y over x using the unit circle. So if we say tan is negative 5 pi over 6, what we do is we look here, we look for 5 pi over 6. The easiest way to do it is starting at 0 always. We count the 6's, including the 3's, in order to get to 5. So we go 1, 2, 3, 4, 5. So it's the same as 7 pi over 6. Another way of doing that is you could take 2 pi and subtract it from there, and you'll get 7 pi over 6. By the way, we're right here. So to do tan, it's the sine over the cosine, or the y over the x. So we're going to go negative 1/2 over negative radical 3 over 2. Now, since they're both got the 2's at the bottom, they're going to cancel. So we're left with 1 over radical 3, so which ends up being radical 3 over 3. That's how you go about that. Same with 3 pi. To find tan of 3 pi, pi is right here, so we just go 1, 2, 3. We're back here. So this one's going to be y over x, so 0 over negative 1, which is just going to be 0. And that's right there because of that point. And that's how you do it. All right, go ahead and try this one. Okay, so let's evaluate secant, cosecant, cotangent of 135 angle. So basically, we need to find sine, cosine, and tangent, and we can go from there. So if we find sine of 135, cosine of 135, and tangent of 135, we get those ones for free. So if we look at 135, it's right here. Sine is going to be a positive radical 2 over 2. Cosine is going to be a negative radical 2 over 2. And those, since they're the same, over each other would just be negative 1. And so from there, we can get the rest pretty easily. Sine goes with cosecant. So that would be 2 over radical 2, which ends up being radical 2. Secant ends up being exactly the same. And then cotangent ends up being exactly the same. That's about it. Go ahead and try this problem. Try this problem.